Yes, okay, good. All right, today we're going to finish up chapter 2. We're going to do transformations. This is, I think, one of the either the easiest or the hardest, depending on how you look at it. Because what is a transformation? If you had to put another word in there, what would you put for transformation? Yeah, exactly. That's exactly what this is. Basically, what this is doing is we start off with a basic function from a library of functions, which I asked you guys to memorize many, many, many times. And then eventually, it changes. So this basic function transforms into this new one. And what happens, really what happens here are four things. The graph moves horizontally. That's left and right. The graph moves vertically. That's up and down. The graph shrinks or stretches horizontally. Or the graph shrinks or stretches vertically. These top two, when your graph shifts horizontally and vertically, what happens here you change the location of the origin. That's what really happens there. Actually, there's a fifth one when we're looking at this. Then we also have reflections. We may have talked about that last section when we talked about the symmetry. Reflection is just that. It's just flipped across either the X or Y axis. Here are some hints. If it happens inside the function, it is horizontal. And it is the opposite. I'll make that, it'll make more sense in a little bit. That's the first one. If it happens outside the function. It is vertical, and it is what it is. Actually, we've actually done the horizontal stuff earlier when we did circles. Remember in circles, if I gave you this equation, if I gave you that, and I ask you, what is the center of that circle? Remember from chapter 1? Nope. Because what did this circle, the original circle looked like this. Let's say 4. Or make it easier for us. Let's make it 2. Because the radius is 2. And what this one says is the center is at 0, 0. Remember, the formula for a circle was x minus h squared, y minus k squared equals r squared. So the original circle looks like this. That's where it's centered at the origin at 0, 0. And it's 2 units each direction. But remember, now I need to have this inside here has to equal 0. Because that's where the center is. This has to equal 0. Because when x is 0, then x is 0. When y is 0, y is 0. So what would it take to make this equal 0? What would x have to be? -2. It's the opposite of what's inside there. What would the y value be? +3. It's the opposite of what's inside there. What happens now is we've shifted our origin from here to there. Because this is r squared, which means radius 2. So our circle looks like this. It's shifted from the 0, 0 to -2, 3. So that's what's happening there. So when we do transformations, this is what's happening. Whatever is happening inside, it is the opposite of what it is. So if it's x plus 2, the answer is -2. If the inside is y minus 3, it's +3. So like I said here, if it happens inside the function, it's horizontal and it's the opposite. All right. So let's look at all 5 of these. The first 2 and the last one are the easiest ones. The reflections and horizontal and vertical shifts. Let's look at them. To begin with, our function, remember we did y equals mx plus b? is made up of this stuff. Where the parenthesis inside there, that's where your function goes. Each one of these letters has a specific purpose on what happens to the graph. We're going to look at C right now. Horizontal shift. So we're only going to look at X plus or minus C. Example. X minus 2 squared. To graph this function, to understand what's going on, here are your steps. Determine the basic function. That's your first step. Because once you know the basic function, you know the graph of that basic function. So first step. What is this function of this equation example? You're also going to need your library of function sheets, since I know you didn't memorize those. Since there's a square here, the basic function is x squared. What does x squared look like? It's the u. And it's touching the origin at the vertex. So that's the first thing we do. Then we determine the horizontal shift, if any. Where do horizontal shifts occur? What's that? It happens, but where in the function does it occur? How do we know if we have a horizontal shift? By looking at the example. Look at your last page that I had on the board. It's horizontal, yes, it's on left and right. But how do we know it's horizontal? It's happening inside the function, right? Since the function is x squared, this is your function. It's happening inside there. So what is our horizontal shift? We have an x minus 2. It happens inside the function. So what's, go ahead. Go ahead, that's not a problem. So where does it move? 2 to the right. If you ever forget, just take whatever's inside there, set it equal in 0, and that's your new origin. So this is your new origin. The graph still looks the same, but now it's just shifted 2 spaces to the right. So again, that happens inside the function. Let's look at another example. This is example one. Let's look at example two. Let's look at this one. What's the basic function? Because everything I'm gonna put here has to be on that library of function sheet I gave you. So which function does this match to? What's that? Cube. It's the cube root. That's the function. What does the cube root look like? What's the graph look like? It looks like an elongated backwards S. Again, you have to know this stuff. I'm not going to explain to you where it came from. What's that? Determine if there's a horizontal shift. Set the equation inside the function equal to 0 and solve. That's how you do it. Whatever's inside the function, set it equal to 0, and then that'll be your horizontal shift. So, which direction does this one shift? Which direction and how many? I just wrote it up here. What did I tell you to do? Set the equation inside the function equal to 0 and solve. So which direction do I move? How far? Right, because I take this equation, set it equal to 0, and solve. So my new origin is at x equals -3. So I move left 3 spaces. So my origin shifted from here to here, 3 spaces to the left. My graph looks the same. Again, I'm not going to slow down. I'm not going to explain how these graphs are what they are because you guys were supposed to memorize these things. And if you didn't, I'm not going to slow down for that. Let's look at the second one. Vertical shifts. Vertical shifts occur outside the function. It's outside the function. You put your x in, work it out, whatever's left, you add or subtract. Vertical shifts are the constant. Is there a horizontal shift? No, because there's nothing occurring to the x. Is there a vertical shift? Yes, because there's something outside the function. What is the function? What is this graph going to look like? One over x. 1/x looks like this. Again, I'm not happy with any of you for not memorizing this stuff in 2 weeks ago. So now we take this graph and we move it up 2 spaces. Vertical shifts, it is what it is. So since I'm going up 2 spaces, there's my new origin is now here. I moved from here, I moved up 2 spaces. So my graph looks the same, but from that vantage point. Graph that one. Graph that one. Is there a horizontal shift? Actually, first off, what's the basic function? Square root of x. What does that graph look like? Right. Starts at the origin, goes like that. Now, always look, is there a horizontal shift? How far where? Very good. Because since that's the function, if it happens inside, that's a horizontal shift. Since it's +3, I go 3 to the left. This is my new origin. So it starts there, looks like that. So is there a horizontal shift? Then is there a vertical shift? Is there a vertical shift? How do we know it's a vertical shift? It's outside and it's a constant. It doesn't have any x's, it's a constant. So it tells me I have to go down 2 spaces to -2. So my new origin is at -3, -2. And the graph looks the same. Again, all we do with transformations is shift the origin to a location and then we'll look at the graph from there. So those are horizontal and vertical shifts happening inside and outside the function. The third one we're going to talk about are called reflections. Remember, this is what every function has the same structure. You have a coefficient, you may have a coefficient in front of the x inside the function. You may have x plus or minus something, and then the vertical shift. And this I put there earlier. So far, what does the value c do? The horizontal shift. Why is it horizontal? It's inside the function. What does the value of d do? So plus d. It's vertical shift because it's a constant. It's outside the function. Now we're going to look at a and b. When we say reflection, we're talking about flipping or rotating, just flopping it over. About the x axis. When we flip, is this the vertical flip? This will be talking about the value of a. If a is positive, no flip. Actually, I'll say no vertical flip. Because the x-axis, if we flip across that, it's a vertical flip going up and down. If a is negative, then flip across the x-axis. First thing to do is determine what are the values of a. What's the value of a of this first one? Remember, a is in front of the function. What value is in front of that function? Yes, positive 1. And in front of g, negative 1. So a is positive here. So this graph just stays the same. It is what it is. Since a is negative, we flip across the x-axis. It's a vertical flip. Here's an example. So the first thing you have to do, look for the basic function. What's the basic function here? Square root of x. Very good. Because it's got to be one of those from your chart. Then the next thing we look at, well, what's the graph of that one look like? Yes. Then we look at, are there any horizontal shifting? So is there anything inside the function? There's an x plus 2. That's inside the function. So what horizontal shift does that make me do? Left 2 spaces. Very good. So there's my new origin. Third step, is there a vertical shift? Right, there's no vertical shift because there's no constant. There's none here because there's no constant. So we still stay the same graph. The fourth, is there a reflection? Yes. Since it's outside the function, it's a vertical flip. So the graph now looks like this. It flips around the x-axis. So I rotate that one, I get this. So if it's outside the function, it is vertical. Same thing with the vertical shift. It's a constant. It's outside the function. If it's outside the function, it's a vertical change. If it's inside the function, it's a horizontal change. All right, let's look at B. Reflection or flip about the y-axis or horizontally. Remember, if it's horizontal, it's inside the function. If B is greater than 0, then there's no flip. If b is negative, then you flip across the y-axis. What do I mean by b? The coefficient of x. B is the coefficient of x. If it's a negative, then we flip across the y-axis. If it's a positive, leave it alone. There's no horizontal flipping. A, which we just did, is the coefficient of the function. It's the coefficient of the function. If it's positive, leave it alone. If it's negative, you flip across the x-axis. Examples. Lord. No. Don't worry about me. Go ahead. I know you're starving. 6 o'clock workout's not good. What's to solve this, to graph this? What are our steps? What's the first thing we look for? The basic function. What's our basic function? Square root of x. Next thing we look for, is there a what? Horizontal shift. In other words, is inside the function, is there an equation? Since there is an equation inside there, take it, set it equal to 0, and solve for x. So that means our horizontal shift is to positive 2. There's my new origin. My origin moved from here to there. So the graph looks like this. Third step. Is there a vertical shift? Since there's nothing outside, nothing added or subtracted to the function, there's no vertical shift. Now we look at, is there a vertical reflection? Where would the vertical reflection be? That's exactly. Very good. Since there's nothing outside and it's positive, leave it alone. Is there a horizontal reflection? What that one is asking is there a negative in front of the x? If the answer is yes, then there is a horizontal reflection. Our graph used to look like this. Now it looks like this. Since I rotated about that y-axis. Not this y-axis, the original one. It's the new one where we shifted our graph. And there's our new graph. So far, so good? Remember, if it happens inside, it's opposite. If it happens outside, it is what it is. Number 4. Let's look at vertical shrink or stretch. Remember, we're always referring back to this. So thus far, we've talked about C. C is the horizontal shift. D is a vertical shift. We only looked at the signs of A and B. If A is positive, nothing. But if A is negative, what happens? We flip across the x-axis. It's a vertical flip because it's outside the function. If B is positive, nothing. If B is negative, we flip horizontally. It happens inside the function. Now we're going to give A and B values, numbers. A is greater than 1. What happens when A is greater than 1? Here's an example. A's in front of the function. 2 is bigger than 1. If we just had the original function, square root of x, let's look at these values. If we did a table, if x is 0, y is 0. X is 1, y is 1. X is 4, square root of 4 is 2. So that's the original one. What happens if we do 2 times square root of x? When x is 0, square root of 0 is 0 times 2 is 0. When x is 1, 1 times 2 is 2. When x is 4, square root of 4 is 2. 2 times 2 is 4. So these points at 1 are up here. At 4, it's up here. So what happened? Yeah, it's going up. So what's happening? Is it, we're talking about shrink or stretch? It's stretching. It's a vertical stretch. If A is bigger than 0, then we have what is called a vertical stretch. It pulls it up and down because the coefficient in front is bigger than 1, so it makes it bigger. I should say the absolute value of A, because if it's -2, it's still stretched vertically, but it's now going upside down. Now, if A, the coefficient of the function, is a fraction or a decimal, what happens there? So again, original function is square root of x. Create our table. Zero, 1, 4. So when x is 0, y 0, 1, 2. When x is 1, y is 1. When x is 4, y is 2. So what does this 1/2 do to my answers? Well, work it out. If x is 0, square root of 0 is 0, times 1/2 is 0. If x is 1, square root of 1 is 1, times 1/2 is 1/2. When x is 4, square root of 4 is 2. 2 divided by 2 is 1. So at 1, it's 1/2. At 4, it's 1. So what did this 1/2, what did that do to my function? It shrunk it. It's a vertical shrink. It pushed it down, made it smaller. This is what I call a squash. It squashes it, makes it smaller. It pushes the function down. Note, this equation could have been written as this. These two mean the same thing. You have to understand the ideas of how fractions are written. A over B is the same thing as A times 1 over B. A over 1 times 1 over B. All these things are the same. Remember what I said earlier, if it happens outside the function, it is what it is. If I multiply by 2, that means I'm making the answer twice as big. I'm making the graph twice as high. If it's a fraction, I'm shrinking it. I'm making it half as small, or 1/8, whatever the fraction is in front. Let's look what we have so far. What's my first step? Basic function. What is the basic function here? The cube root of x. And that graph looks like this. When x is 1, y is 1. When x is 8, y is 2. When x is -1, y is -1. When x is -8, y is -2. So we have 1, 1, 8, 2, -1, -1, -8, -2. What's the first shift we look at? It's a horizontal shift. Is there anything inside the function? Yes. So what do you do with that equation inside the function? Set it equal to 0 and solve. So we see our shift. We're shifting x to +2. So this is my new origin. So the graph still looks the same. Horizontal shifts only change the x values, not the y values. So what are my new points? What are my new points? I started off at 1, 1, 8, 2, -1, -1, -8, 2. Well, plug them in there. Look at remember, horizontally is only x. So my x value here in the first from the first point of my new origin is 1. 2 minus 1 is 1. So what's the new location? I shifted it how many spaces? 2. So from 1, 1, I added 2. Then from 8, 2, I added 2, so it becomes what? 10. At negative 1, I added 2, so I got 1. At negative 8, I added 2, so I got negative 6. So it's whatever your x value is. You either add or subtract it to your previous values. Next, is there a vertical shift? Is there a vertical shift? Yes, since there's a constant, which means it's negative 1, so I go down 1. So I go down to negative 1. So my new origin is at 2, negative 1. And the graph again still looks the same, has the same shape. But now, from 3, 1, 10, 2, 1, negative 2, or 1, negative 1, and negative 6, negative 2, what are my new values? I only did a vertical shift, so this is still 3, and this is still 10. But what are my new values for the y values? I subtracted 1. So for all my y values, I subtract 1. 3, 1 now becomes 3, 0. 10, 2 now becomes 10, 1. 1, negative 1 becomes 1, negative 2. And then negative 6, negative 2 becomes negative 6, negative 3. So what this one says is subtract 1 from the y values. This one here says add 2 to the x values. Because it's positive. If it was negative, it'd be subtracted 2 from the x values. And if this was positive 1, we'd add 1. So far, so good? Because this is what we're trying to get to. Because not only, yeah, we could do these small ones, but I'm going to give you a graph in a minute after we do all these. And I'm going to say, find me the new locations. I want to know the points, not anything else. Because you're not going to give it a function. There's no function. Okay, so we looked at the basic function, horizontal shift, vertical shift. What else is there to do? Is there a vertical reflection? No. Very good. Because it's positive. So there's no vertical reflection. In other words, it doesn't flip across the x-axis. But there is a vertical what? Is it a shrink or stretch? Stretch, because it's bigger than 1. So what this one tells me to do So, the horizontal and vertical reflection, we'd look at those. None, because actually, yes, there is. Hold on, there is a horizontal reflection. Is that what you're going to tell me? Yes. Because in front of X, there's a negative. There is a horizontal reflection, which means our graph. Good catch. Thank you. Remember, our new origin is at 2, -1. A horizontal reflection, we flip across the x-axis. So this 3, 0, flip it across this axis, is now 1, 0. And this 1, -2, when I rotate it, becomes 3, -2. The graph looks like this now. And 10, 10, 1, when I rotate it, it becomes what? Since it's 8 spaces over 8 spaces here, I go back 8 spaces over here. So this 10, 1, when I flip it over, since I shifted over 2 spaces, becomes -8, +1. And this -6, 3, since I shifted over 2, becomes +8, -3. There's no vertical rotation because the leading coefficient is positive. Vertical, shrink, or stretch. What this thing does, what the vertical shrink or stretch does, is multiply to the y values. So each of our y values in our graph is multiplied by 3. So from -8, 1, it becomes -24. No, to the vertical to the y values. So it's -8, 3. So from -8, 1, I multiply to the y value 3. So it's -8, 3. At 1, 0, it stays at 1, 0, because 0 times 3 is 0. The origin stays where it is. The origin stays where it is at 2, -1. Then we had a point at 3, -2. So it becomes 3, -6. So the graph is just stretched up. Okay, here's a question. Somebody would say, why doesn't the new origin change position? Let's look at it. What's the location of the origin? It's at 2, -1, right? If I plugged in 2 in place of here, what do I get? 0. So I have at 2, I get -1. It never changes. So the origin stays, once you get a new origin, stays fixed. Everything else shrinks, stretches, moves. All right, so that is our vertical stretch and shrink. Again, if it's outside the function, it is what it is. Now for this is 5. This is 5. Horizontal shrink or stretch. The horizontal shrink or stretch, all dependent on B. Remember, if it happens inside the function, do the opposite. If it was x plus 3, your horizontal shift would be +3. Or if it was x plus 3, it'd be -3. It's the opposite of what's inside there. The same goes with the shrinking and stretching. If B is greater than 1, then we have a horizontal shrink. By dividing the x value by B. If B is a fraction, then we have a horizontal stretch. By multiplying x by b. Or whatever the reciprocal of whatever the coefficient is. Because, again, it's opposite. Let's look what happens here. So is it going to be a shrink or a stretch? It's going to seem like it's been squashed together. We'll see why in a second. The original function is square root of x. At 0, 1, and 4. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. Now we have square root of 2x. Let's look at this graph. When x is 0, y is 0. When x is 1, we have the square root of 2. Square root of 2 is a little bit bigger than 1. When x is 2, when x is 4, we have square root of 8. Square root of 8 is the same thing as square root of 2 times 2, which is pretty close to, let's say 3 point something. Keep these values the same. I would have to divide these numbers by 2. So what's really happening in this one, if my original graph had xy, and I had f of 2x, then my new graph would look like x divided by 2y. And if I had that, so I have a coefficient that's between 0 and 1. So that means it's going to make it longer. So basically what that means, for whatever point I had originally, I now multiply my x value by 4. Why do I multiply by 4? It's the same rule. I'm still dividing whatever the coefficient is, whatever my x over b is, it's still the same thing here. If I had x divided by 1/4, the rule is take the top, leave it alone, and multiply by the flip of the bottom. So that's it. Well, yeah, we're done. Actually, this is the end of it. You don't have to ask. Just close whatever it bothers you. Just close it. You don't have to ask. So these are our transformations. Again, what it does. -3, 0. -2. If I had this graph, and my function was that, what would my new graph look like? If it's outside the function, what do you do with it? Multiply each of the y values by 2. Because outside of the function is a vertical shift. Vertical is the y-axis. So I would multiply all the y values by 2. What would I do here? I would divide all the y values by 4, or multiply by 1/4. If I had this, what would I do? Because it's bigger than 1, I would divide each x by 3. So this -3 would be -1. This -2 would be -2/3. This 1 would, so it would shrink. It would push it all together. If I had this, multiply each x by 2. What did I do there? Because no, I'd move the entire graph 2 spaces left. Remember, if it's inside, set it equal to 0. That's what I'm doing to every point. I'm moving it over 2 spaces to the left. because it's positive. That's what you're doing here with these kind of functions. But what matters is that you guys know what the functions are. That's why you need to memorize the library of functions. There are 12 of them. Because if I ask you to graph them, I'll just give you a function to graph it. Yeah. You're supposed to memorize those 2 weeks ago. So it's going to make life easier for you. Okay, that does it for chapter 2. Yeah, I should take a picture of these sheets if you want. Yeah. With the whole thing here. Pick whatever pages you need. Get number them. Over here.